Okay, now let's finish off this section. It got rather long. So what we need to do is we need to subtract these two and add these two rational expressions. And so what we have to do is we have to find our LCD. So first thing we need to do is factor each of our denominators. And so on this one, it looks like it's going to be x minus 3x plus 1, because if we take that, that's going to be minus 3, and we have minus 3x plus 1x is going to give us a minus 2x. And here we have x plus 1, x plus 5. So what does that give us? Well, it gives us an LCD of x minus 3, x plus 1, x plus 5. Okay. Now we need to rewrite each of these expressions with the new LCD here. So that's a 2x plus 7 over x minus 3, x plus 1. And we have to multiply that one by x plus 5 over x plus 5. Then we have minus. Now we have 3x minus 2 over x plus 1, x plus 5. And we have to multiply this by, well, now we have to multiply by x minus 3 over x minus 3. Okay. Now what we're going to do is we're going to FOIL the numerator and FOIL the numerator here. And so that's going to give us 2x squared. Then we have 10x plus 7x, so that's plus 17x. And then plus 35 all over. And then we have x minus 3, x plus 1, x plus 5 minus, now because of the minus, we have to find out what we have here first and then distribute the negative through. So we have 3x times x is 3x squared. Then we have minus 9x minus 2x. So minus 9 minus 2 is going to be minus 11x. And then we have a minus 2 times a minus 3, so that's going to be a plus 6 all over x minus 3, x plus 1, x plus 5. Now, when we change this, we have to distribute that negative throughout. Okay, so when we do that, we'll have 2x squared plus 17x plus 35 minus 3x squared, and then plus 11x, and then minus 6 all over. And then we have our x minus 3, x plus 1, x plus 5. Now this gives us what? Well, 2x squared minus 3x squared is going to be minus x squared. And then 17 plus 11, that's going to give us 28x. And then we have 35 minus 6, that's going to give us plus 29 all over x plus 3, oh, minus 3, let's change that to a 5. X plus 5, x plus 1, x minus 3. Now, can we factor this? Well, what's going to happen? Let's pull out a negative 1. And then we have x squared minus 28x minus 29. And so that then is x minus 29 and x plus 1. And so it looks like our x plus 1 in the denominator cancels that one. We still have the negative out front. We have that in the numerator. So that becomes a negative x minus 29 over, and then on the denominator we have x plus 5 and x minus 3. So then that will be our final answer to taking this rational expression minus this one. All right, what about the next one? Again, more factoring included. We have to take and say, well, that's going to be what? Well, that's going to be x plus 4, x plus 2. 2 times 4 is 8. 4 plus 2 is 6. And here we have x plus 2, x plus 1. So that gives us an LCD of x plus 4, x plus 2, x plus 1. And rewriting each of these rational expressions with our new LCD, we have 3x minus 7 over x plus 4, x plus 2 times what? Well, we're going to have to multiply that times x plus 1 over x plus 1. And plus 3x minus 3 over x plus 2, x plus 1, and we're going to multiply that one by x plus 4 over x plus 4. All right, so since we have a plus here, we can just FOIL and write it all in the numerator. So 3x times x is 3x squared. Then we have 3x and then minus 7x, so it's going to be a minus 4x, then minus 7. Then we have 3x times x is going to be plus 3x squared. Then we have 12x minus 3 is going to be plus 9x, and then that's going to be minus 12 all over. Then we have x plus 4, x plus 1, x plus 2. All right. So simplifying, that's 3x squared plus 3x squared, that's 6x squared. And we have minus 4x plus 9x, that's going to be plus 5x. And then we have minus 7 minus 12, that's going to be minus 19 all over x plus 4, x plus 1, and x plus 2. And somewhere that one. Now, this one appears to be going to be factored into 2, and I'm going to test out 6x and x, and then I'm going to say if I take 19 and 1, 19 minus, that's not going to work, so we're testing out here what's going to be the case. Maybe nothing cancels is going to be the key. Let's see, 2x and x, 2x and 3x. That's, Okay, so looking at this, 2's and 3 don't work, 6 doesn't work, and so that means this is the final form. We can't factor this any further, and so that would be our final answer there. All right, let's move on. Now we're going to do things as listed as a function, but really they come down to the same thing as what we just have done here. We're going to add or subtract two rational expressions. So if we look over here, f plus g of x, here's our f of x, here's our g of x. That really just says take f of x plus g of x. So that's what we're going to do. We're going to take x over x plus 7, and then we're going to add. Now, if we think about this, let's go ahead and factor this so we can write it as it is. So that's x plus 7, x plus 3, and so we have 10x plus 42 over x plus 7, x plus 3. All right, so what do? Well, our LCD is x plus 7, x plus 3. Okay, what does that mean? Well, we have to multiply this one times x plus 3 over x plus 3. And again, we're going to distribute that x to both of those. So that gives us x squared plus 3x. Now we have the denominator here already the same. So then plus 10x plus 42 all over. And then we have x plus 7, x plus 3. Okay. Well, this gives us x squared plus 13x plus 42 over x plus 7, x plus 3. Well, can we factor this? Well, this can be factored into, looks like x plus 6, x plus 7, because 6 plus 7 is 13 and 6 times 7 is 42. So that helps out because x plus 7 cancels. And so we get x plus 6 over x plus 3. This can't be reduced, and so then that is our final answer for f plus g of x, given our f of x and our g of x. Okay. Now if we did adding here, well, guess what? We're going to do subtraction too. Now we have r and q. And so again, this means we're just going to take r of n minus q of n. And so we have r of n, we have q of n, so we're just going to take n minus 2 over n minus 3 minus. Now let's go ahead and factor this here. So that's n, 15 is 3 and 5. The large one has to be positive, so plus 5n minus 3. So that's going to be 11n minus 25 over n plus 5 n minus 3. Okay, well, our LCD is n plus 5 times n minus 3. And so our first rational expression, we have to find a new LCD because, or write it out because we don't have the right term in the denominator. So we have to multiply by n plus 5 over n plus 5. Now we're going to FOIL that. So n times n is n squared. Then we have a minus 2n plus 5n. So it's a plus 3n. And then minus 10 over n plus 5, n minus 3, minus 11n minus 25 over n plus 5, n minus 3. Now remember, when we subtract, we have to remember to distribute that negative across. So that's n squared plus 3n minus 10. Then we have a minus 11n, and then we have plus 25 all over, and then we have n plus 5, n minus 3. Okay, so looking at that and simplifying, it just gives us n squared, and then we have a minus 3, or plus 3 minus 11. So 11 minus 3 is 8, so it's going to be a minus 8n. And we have a minus 10 plus 25, so it's going to be plus 15 all over n plus 5, n minus 3. Now, how do we factor this? Well, that's going to be a negative and a negative, so n minus, and 3 and 5, because 3 times 5 is 15, and 3 plus 5 is 8. And we see that there is a common term in both of those. It's the n minus 3, so we can cancel those out. And that gives us our final n minus 5 over n plus 5. Now those aren't the same, so we can't do anything, and so that's going to be our final answer. All right, so that's all I have for this last section.